So this is the system generator, as you guys know. So you've used it in the past, so great. So you can see we have a lot of blocks over here. So basically what I'm doing here, I'm building a DDC system. Basically we take the signal after it gets digitized by the ADC, and I'm mixing it using a mixer, and then passing it through a low pass filter. So basically using the mixer to bring the signal to the baseband, and then I filter out the high frequencies, and then I demodulate it. So this is a different topic. It's going to be covered in the next videos, but for now I just want to focus on the bandpass sampling theorem, and I want to use this live demo to prove some key points here. So what I'm doing here, I have an FM signal that's simulated. So let's see what we have here. So we have a 10.7 megahertz as a carrier frequency, and then I have a deviation of 75 kilohertz, and then the message signal I believe is 5 kilohertz. Great. And then we sample this FM signal with a 10 megahertz, and it is simulated to be a 12-bit ADC. So let's see what's going to happen. So I'm going to run the system, run the simulation, and we'll look at the spectrum of the captured signal at the output of the ADC. So it's coming, so it's going to take it won't take too long, so just bear with me. It's done. Okay, so now we go to our workspace, and we have 10 megahertz here. We'll run it and see what's going to happen. Great. So we covered our FM signal. So let's change the scaling on the x-axis just to make it easy to see. So let's move this to 1 megahertz, and here you go. So we got our spectrum centered at 0.7 megahertz as we expected, and we have a bandwidth of 200 kilohertz with a lower frequency of 0.6 and an upper frequency of 0.8 megahertz. So now let's quickly go and change the sampling frequency to 1 megahertz. So let's do that quickly here. I don't want to take too much time of your time. So let's change this to 1 megahertz and quickly run it, and then we just save and run. There you go. It's running. And it is done. So now we can go to our workspace again, and then change the sampling frequency to 1 and save and run. There you go. So this is our spectrum. Now we have a center frequency of 0.3 megahertz as we expected, and we have a bandwidth of 200 kilohertz, and we have side bands spaced by 5 kilohertz, which is the message signal. So now probably, if you guys don't mind, I can do a single tone and see how it is. So let's get rid of this, we don't need, and we can just use a single tone over here and see what's going to happen and how it's going to alias. So let's move this here and then change this to, let's just make this 0. This is just sampling frequency, we don't care too much about it, and let's make this 10.7 megahertz, e to the 6, and apply. Okay, and then save, and then we run it and see. So it's done. Let me remember here what we did. So we did, I believe, 1 megahertz sampling frequency. So we go back to our code here, and we have 1 megahertz here already. So we just run it and see what we get. So exactly, we get 0.3 megahertz as we expected. So maybe now we go back and change that to a sampling frequency of 10 megahertz and see what's going to happen. Just quickly here we do that. Apply, okay, save, and run it. So it's done. So we go back to our workspace and we change this to 10 megahertz instead of 1 megahertz for the FS, and we run it. So let's see here, change the scaling over here, the x-axis, and we make this thought we can change it. Why it doesn't give us axis properties? Change this to 1. Hit enter. So exactly, so we got a frequency aliased at 0.7 megahertz, and that's exactly what we expected. So I'm not sure if I mentioned how this data gets exported. So this data gets exported to workspace by using this block called to workspace, and I named it ADC out. So this is pretty much it in terms of this live demo. So I hope you guys learned something from it. So now I'm going to go back to our PowerPoint slides and conclude this video.